नमस्कार. आपण व्हेक्टरमध्ये आज थेरम पाहणार आहोत. काही थेरम नंबर 5, सेक्शन फॉर्म्युला फॉर इंटरनल डिव्हिजन. What is the statement of section formula? Let A, point A with position vector A bar and point B with position vector B bar. Let A bar, B bar be any two points in the space, and R bar be a point on the line segment AB, dividing it internally in the ratio m:n. Then this R bar is equal to m into B bar plus n into A bar upon m plus n. What this section formula says? Section formula says that if point R divides the segment joining A and B internally in the ratio m:n, then section formula gives relation between their position vectors. So let us prove this result. As R is a point on the line segment AB and R lies between A and B, R is point on line segment AB and R divides AB internally. So R lies between A and B. Here is point R. Here is A. Here is B. And ratio AR is to RB is m:n. So this vector, we have to look at the vector AR bar, vector RB bar. Let O be a fixed point, and with reference to O, position vector of A is A bar, position vector of B is B bar, position vector of R is R bar. Now AR and RB are in the same direction. AR and RB are in the same direction. There and this is given. AR is to RB is m:n. So n into AR, this n into AR is equal to this m into RB. Now if we see vectors NAR and MRB, these vectors have equal magnitude and same direction, and therefore MRB is equal to NAR. Now this vector RB can be looked as OB minus OR. This can be established using triangle law of factor addition, and AR can be expressed as position vector of R minus position vector of A, that is OR minus OA. If we simplify this and find the value of R bar, here OR represents R bar, we get this relation. So this is the proof of section formula for internal division. What section formula says? Section formula gives a relation between position vector of 3 points. If point R divides AB in the ratio m:n, then this is the relation between their position vectors. Now we know if coordinates of point P are x, y, z, then its position vector is xi plus yj plus zk. So there is a relation between coordinates of point and position vector of that point. Now since we have this relation between the position vectors, a similar relation can be obtained in their coordinates also. So here we have remark, if point A has coordinates a1, a2, a3, B has coordinates b1, b2, b3, and point R has coordinates r1, r2, r3, and if this point R divides the segment AB in the ratio m:n, then this R1 is equal to m b1 plus n a1 upon m plus n. This R2 is equal to m b2 plus n a2 upon m plus n, and this R3 z coordinate of point R3 is equal to m b3 plus n a3 upon m plus n. So in short, we can write these three relations as Ri is equal to mbi plus nai upon m plus n, where I varies from 1 to 3. This can be obtained, this can be proved by using our section formula. Now here this bar should not be there, this bar should not be there, because these are coordinates, and not vectors. This bar should not be there, relation between their coordinates. Next, midpoint formula. If r bar with position vector r bar is the midpoint of the line segment AB, then m is equal to n. Ratio m is to n, it will become 1:1 if m is r is the midpoint. And therefore in section formula, if we read m is equal to 1, n is equal to 1, we get r bar is equal to a bar plus b bar upon 2. This is called midpoint formula. The position vector of the midpoint of segment AB is given by a bar plus b bar upon 2. Now after these two remarks, we move to the next theorem, that is theorem number 6, section formula for external division. Now what is external division? Point 3 points A, B, C and say R, A, B and R are collinear, but R does not lie between A and B. Then we say R divides segment AB externally. Let me read the statement. Let A bar, B bar be any two points in the space, and R bar be a point on the line segment AB, dividing it externally in the ratio m:n. Then R bar is equal to mb bar minus na bar upon m minus n. Now let us see the proof. As the point R divides line segment AB externally, we have either R, this B lies between A and R is outside AB, or A lies between R and B. So we assume one of these two possibilities. Let us say B lies between A and R, and ratio AR is to RB is equal to m:n. AR upon RB is m:n. So n times AR is equal to m times RB. N times AR is equal to m times RB, and vectors AR and RB have opposite directions. Their directions are opposite, and therefore n times AR is equal to m times BR. Here we are talking about RB. Now here I have taken BR and AR have same direction. Now we convert this into their position vectors. This n times R bar minus A bar, position vector of second point minus position vector of first point. m times position vector of second point minus position vector of first point. If we simplify this, we get the required relation between position vectors of points A, B and R. We have one note on this. Now this note is general. What it says, whenever the ratio in which point R divides the join of two points A and B is required. Sometimes we may be asked to find ratio. So whenever ratio is required, we are asked to find ratio, it is convenient to take the ratio as k is to 1. That means it is not necessary that we always should start with m is to n. We can take that ratio as k is to 1 also. Now while solving problem, this instruction, this note will help us. Now we will solve problems. But before going to problem, let me prove two formulae. One is called centroid formula. In triangle ABC, centroid means the point of intersection of three medians. Centroid G divides the medians internally in the ratio 2 is to 1, and G bar, the position vector of centroid, is given by A bar plus B bar plus C bar upon 3. We can prove this result. But here only statement of the result is given. What this statement says, we have triangle ABC with vertices, position vectors of vertices A bar, B bar and C bar, and we are asked to prove that the point of intersection of medians divides each median in the ratio 2 is to 1. At present, I will just write the statement of this result. In the next lecture, we will prove this result actually. I will give you detailed proof of this result. Now, one more similar geometrical figure is tetrahedron. Now, why it is called tetra? Because it has 4 faces. This is a solid figure, and this solid figure has 4 faces. Each face is a triangle. On every face there is a centroid of the triangle. So here if we look at the base triangle is triangle DBC, and its centroid is at E. Then this triangle ADC is one face. The centroid of this triangular face is at E. Its opposite vertex is B. The opposite vertex of centroid E is A. If we join vertex with the centroid of the opposite face, these segments, all these 3 segments meet in one point, and that is denoted by G, and it is called the centroid of the tetrahedron. In tetrahedron ABCD, centroid G divides the line joining vertex of tetrahedron to centroid of opposite triangle in the ratio 3 is to 1. This ratio AG is to DGE is 3 is to 1. This ratio is 3 is to 1. We can prove this result using section formula, but right now I am just giving you statement. Now first we will solve some problems, and after solving some problems we will come to the proofs of some geometrical theorems. First problem. These are very elementary problems, applications of section formula to understand the statement. Find the coordinates of the point which divides the line segment joining points A 2 minus 6 8 and B minus 1 3 minus 4. So coordinates of 2 points are given and we are asked to find coordinates of the point which divides segment AB. First case internally in the ratio 1:3 and second case is for external division. So for this, let me write position vector of point A. Position vector of point A, which is denoted by A bar, is equal to 2i minus 6j plus 8k, because coordinates of A are 2 minus 6 8 and therefore this is A bar. From coordinates of B we write B bar. Suppose first case point R with position vector R bar is the point which divides line segment AB in the ratio 1:3 internally. Then R bar is equal to M B bar plus N A bar upon M plus N. M is equal to 1, N is equal to 3. If we simplify this, we get value of R bar like this. And therefore coordinates of point R are 5 by 4, which is coefficient of I, minus 15 by 4 and 20 upon 4, which is 5. So these are coordinates of point R which divides segment AB internally in the ratio m:n. For external division, procedure is same, only here we have to take minus sign. M B bar minus N A bar upon M minus N and make respective changes in calculation. Again I have denoted that point by R. Here you can see I have changed the sign, and if we simplify this we get position vector of R, and from position vector of R we can write coordinates of R. This minus 7 upon minus 2, that is 7 by 2, minus 21 upon 2 and minus 28 upon minus 2, that is 14. These are coordinates of the point which divide segment AB externally. Then second question, if 3 points A, B, C are collinear, then find the ratio in which this point C divides segment AB. And we are also asked to find the values of P and Q. They are unknown. Now if we denote position vectors of A bar, B bar and C bar, A, B, C by A bar, B bar and C bar, then A bar is equal to, look at the coordinates of A, 3 2 P, and therefore A bar is 3i plus 2j plus pk. If we see coordinates of B, this is B bar. Coordinates of C will give me C bar. Now suppose C divides segment AB internally in the ratio t:1. We do not know whether ratio is internal, division is internal or external. Even if we assume that division is internal, ratio is t:1 and actual division comes to be negative, external division, then ratio will be negative. Automatically we'll come to know about that. Then by section formula we have C bar is equal to TB bar plus 1A bar upon T plus 1. First we will find ratio in which C divides AB. Okay, so we use these position vectors of C bar, B bar and A bar and simplify this. After simplifying this, we equate vector in left side and vector in right side. So this coefficient tq plus 3 must be equal to coefficient of I in left side. Coefficient of j in right side must be equal to coefficient of j in left side. So this coefficient of j gives me the value of t, and if I substitute this value of t, see t is negative, that means division is external. T is negative, that means division is external division, and if we put this value of t here, then we can get values of p and q also. You check these calculations. Now here is one remark, that negative sign of t suggests that C divides segment AB externally in the ratio 5:11. So this was second problem. Now let us move to the third question. What this third question says: if A, B, C are vertices of a triangle and G is its centroid, then find values of P, Q and R. Here is P, here is Q and R. Again we write position vectors of these points, 4 points, using their coordinates. Here are the coordinates and these are their position vectors. Then by centroid formula, this G bar is equal to A bar plus B bar plus C bar upon 3. So 3G bar is equal to A bar plus B bar plus C bar. 3G bar is equal to A bar plus B bar plus C bar. And simplify this, equate coefficients of I, J, K in left side and right side. We get equations in terms of P, Q and R. Solving these equations, we get values of P, Q, R. So this is question of algebra only. Only we have to equate coefficients, make simplification and find the values of P, Q and R. Let us discuss this sum also. If A bar, B bar, C bar are position vectors of points A, B, C respectively, and we have given this relation. What is this relation? 5A bar minus 3B bar minus 2C bar is equal to 0 bar. Then find the ratio in which point C divides line segment BA. We have to take help of this equation. Using this equation, we can find value of 2C bar. 2C bar is equal to 5A bar minus 3B bar. From this equation, I can write C bar is equal to 5A bar minus 3B bar upon 2, and these 2 can be viewed as 5 minus 3. And from this, if we compare this with section formula, we come to know that point C divides segment BA externally in the ratio 5:3. We have to compare this with section formula for external division and write the answer. Answer is ratio. In what ratio? C divides BA. The required ratio is 5:3. And I stop my today's lecture with this problem. In the next lecture, we will solve problems based on section formula. A number of problems are there which are based on section formula. So in the next lecture, we'll discuss those problems. Dhanyavad.